Alrighty, so this video is going to have a look at how we can create a population pyramid that is starting to combine data sets, multiple data sets. So it's a really good way to do a bit of a comparison of either two periods of time for the same location or two different locations. So it could be the location that a student has picked for an IO3 plus the state, so Queensland's data or whatever state you're looking at that location. So you can see here, I talk to my students about, population pyramids. Really, part of that discerning element is they can elect to either do it as percentage, and my students do that as their initial transformation of data. So they've already done a population pyramid where they've looked at the percentage breakdown. This time around, I actually think it's more appropriate to use the raw data. And the reason why I think it's more appropriate is if you're doing percentage comparison, well, the percentage might change. It's proportionate to that whole population. However, a student can really identify where age groups have increased or decreased in much more detail with the raw data. And when you're looking at the same scale, so when you're looking at the same location, it's fine. If you're looking at different scales of data, obviously it would make more sense to compare versus on a percentage basis. So we're looking at the same location here. This is for Jimboomba. You can see 2015 versus 2020 data. So it's just from ABS. So we're going to use the same process that we have always used. And obviously with males, we're going to have the negative. I've done a video before on how to do the formula if you want to do the percentage breakdown, so you can have a look at that. We're going to go to recommended graphs. We're going to use clustered bar. So this is where I've seen most of you have gotten up to. We're just going to move that to a nice clean sheet. All right, so there's a few things that I like to do before we get into the nitty-gritty. So we're going to move our axes across. Everyone's pretty switched on about all of this now. So I'll just move through it. You can obviously pause if you semicolon 0. That removes those negatives. All right, now I'm going to go and do something where this is where it basically becomes a little bit funky. We're going to do a combination graph. And just looking across, we're just going to make sure everything is a clustered bar. But we're going to make the first and the last on a secondary axis. So males 2015 and females 2020, we're just going to make on a clustered bar. And it, makes it look funky. So now we have this secondary x-axis, and we're just going to delete that, and voila, you have an aligned population pyramid. So, pardon me, depending on what you want to do with it, you can start making specific colours. So I like to think of it as I'm looking at two different years. I might make my 2015s the same year. So it's going to be our grey. Let's go here. And this one, just make sure it's the same colour. And my 2020s. No, that's fine. It's the same colour. All right, if I just jump back to my chart, what I'm going to do now is as well, just change one of my 2015 data sets to the actual year, and same with the 2020. And now I'm just going to delete these extra ones. So now I've just got the 2 different years. And then I might also want to change my gap width. So normally about 70 is nice. And I'll do that for the other side. So that makes it nice and thick. Alright, then the last thing what I'll do is add some text boxes. And I will put my males. And my females. And now you've got a completed population pyramid where a student can really clearly identify and separate really nicely pre-reproductive, reproductive, post-reproductive age groups, and how we've seen expansion in certain areas, and specifically for Jimboomba's case around that family style or the family groups, how that's increased. So hopefully this is a helpful tool to get your students to really start breaking out into looking at those relationships in their data. Thanks.